Project that was designed for animal research, and what it does is allows us to exercise an animal using a voluntary exercise wheel, similar to like in a hamster cage or a rat cage, but it allows researchers to control the intensity of the wheel. So in order to do that, we've got an infrared sensor that senses the running area, so that when the animal gets in, the wheel turns on to a certain intensity. So we can control the speed of the wheel, but at the same time make it as voluntary as a regular hamster wheel. And in addition to that, we've added electronic food pellet dispenser, so that as the animal exercises, we can feed it to reward it for that kind of behavior. So everything is done electronically, set through this control pad, and then the device pretty much takes care of itself. The first component of this is the pellet dispenser, and the way this works is there's a stepper motor inside. You can kind of see there, and the whole thing is just a rotating drum. It's a hopper that's fed by gravity, and as a pulse is sent to the circuit board, it's analyzed by a PIC microcontroller that then drives this stepper motor. And so what happens is the device will turn a certain number of degrees to allow different holes in the levels to line up and allow one food pellet to drop at a time. The different components that are involved in the control box, there are a couple of things here. The first is a stepper motor, and this is what allows us to drive the speed. So we control this by adjusting the frequency of the wave going into the motor. We've also got a keypad to allow for the input of data to prompt the user for different variables, and then also an LCD display to show what's going on and give a little bit of feedback. This is the bottom side of the control box, and you can see the circuit board that was designed. This is the infrared sensor that is able to tell if an animal is present or not, and it consists of an infrared transmitter that sends a signal out, and ideally it bounces off of something and comes back to the receiver. And the distance of that travel can be changed by a potentiometer on the back to adjust the wavelength of the light beam. The device is controlled by a PIC microcontroller, 16F877 to be exact, which gives me a lot of I/O capability. And then some of the other components that are players are the stepper motor driver. So we've got a controller and a dual full bridge driver that controls the stepper motor. It basically translates a clock pulse into one step of the motor, so I'm not required to control the coils and the phases independently. There's also another PIC microcontroller that runs the infrared sensor, but all these things are run by the main one that I first mentioned. So when the device is powered on, the first thing that the user is prompted for is a wheel RPM. So I use the keypad to enter in the desired RPM, and then I've got a couple of different menus, a train and a run program. And the train I change based on trying to get an animal to act a certain way. But the important one is the run program, so I'll select that one. It asks for the active minutes. How often do I want the animal to be in the device, and how long do I want that period to be active so that it can obtain food. So I'll go ahead and enter in 15 minutes for that. And then the next thing it asks is how long of a delay period. So between active periods, how long do I want it to wait until it's allowed to go back in and get more food. So I'll enter in 1 minute for that. And then how many revolutions does it have to run before it gets rewarded for food, rewarded with food. So I'll just put 5 revolutions in. And then how much do I want to feed it after it's run that required amount. So again, I can enter in anything I like. And so at that point it goes into a monitoring stage. And so as the animal runs revolutions, it keeps count on the display. And right now, someone can figure out how much the animal is fed by keeping track of the variables that were input in earlier. Right now the device is in the active mode that was set earlier. So you can see that as a mouse enters the wheel is made active. Yeah, the ball helps you see that the infrared sensor is what triggers the wheel active. So as it wanders in and out of the sensing range, the wheel stops moving. And that's real helpful because as a mouse sometimes likes to cling on to the wheel, if it gets up to the top, if it decides to get to a point where it might injure itself and get pinched up here, the infrared sensor keeps it from traveling too far.